All right, should we let's get started. We'll talk about the laser and the vinyl cutter and the water jet. So let's see. Can I share
Are
my
we going to be required to cut something on the water jet?
No.
I would like to.
You should.
Yeah, I have ideas, but
it's really cool. And I will say that cutting a vinyl record album was really satisfying. I mean, metal is awesome, but there's like, you know, there's a piece of like stone in the back that could be cut, and I really enjoyed doing the record. So a lot of options.
like you put a actual record and then you lasered through it?
Yeah, I used the water jet. Yeah.
And what did it make? What did you make with it?
I just cut out the shape of the MakeHaven robot, just kind of as a test to see if it would work.
That's really cool.
Yeah, it's a fun medium.
Yeah. I'm always scared I'm going to break it though, because I've never used it. That's all.
The what?
The water jet.
Water jet.
Water jet.
I would say, I know we're like totally getting up, but two things about the water jet is just be careful about your placement so you don't smash it and have to pay $100. And also, I like the first time that I worked with it, I just did my project during facilitator hours, so I kind of had like a spotter.
That's a key move. Figure out when Alex is there and try and do it then.
Yeah,
because he's a pro. So yeah, let's
pictures.
Oh,
sorry. Okay, I put the pictures of the kiln in the foundation Slack thing.
Thank you.
Oh, that's awesome. I really enjoy how much we're all gelling around getting things done, making stuff happen. It's lots of fun to watch the group like help each other in the dynamic of what's going on. So it'll be fun to see over the next little while, like how people build and how we can share designs. And if there's anything that's really clever that one of us figures out, how we can help each other with all those details. But that said, let's officially get started with the slides. We'll sort of work our way through. We'll have discussion. I think that you guys are going to have lots to add to this week. So I'm ready at any point. If you've got something that's in your head that you want to get out to the group, please unmute, let us know. There's plenty of good things to talk about and ideas that you will have had that I will not. So feel free at any point to chime in. And that said, let's get started. So vector design and making. We're going to cover a whole range of topics today, but it's important to know that there's going to be more things that come up with this next week. The first things that we're going to talk about are raster and vector, just to draw a clear distinction between those two, identify what they are, how their interplay works, and sort of what's the relationship going on there. Then we're going to go through the design software options because there are many, one of which is free, probably just one or two. And then a few more that are really great that people absolutely love. So we'll take a look at those to see what we've got as options. Then we'll go through some concepts. We'll talk about vectors as toolpaths and why that's different from vectors for art. And then we'll start design for the laser, design for the vinyl cutter, and design for water jet, just to get us going in that direction. And really, laser and vinyl are the goal here. Water jet is not a hard push beyond those two. So if you're totally a pro at the laser and the vinyl cutter already, getting to the water jet would totally be something that's in scope with this concept. But let's first, just for the sake of clarity, making sure that everybody knows this, because you might already, but you also might not. It's good to go over the difference between raster and vector, specifically what it means for files, and then we'll get to what it means for the laser machine later. So I actually have this lovely little clip that I want to let play, and hopefully it will record. Let's see if I'm sharing. Ooh, if I share the browser, I think it will. I'm going to stop sharing briefly because I think that it will let me record audio if I do this. Share and that, and now hit play.
There were two principal paradigms for rendering an image on the screen: raster and vector. Raster comes from the Latin word rastrum, meaning rake, and today is the more familiar method of drawing on screen. The electron beam rapidly sweeps every line of the display in sequence, forming a grid. line by line, a picture is assembled. Vector graphics directly manipulate the electron beam to form their images in a similar manner to an oscilloscope. Indeed, very early games like Tennis for Two used an oscilloscope display.
All right. So here's the deal. I get that you can't hear it. And so point taken, we're going to stop with that. And let me just briefly buzz through to like key items on here. Sorry, I was hoping that would work better than it did. The presenting with sound is always a struggle. Oh, closed caption. Good call. So in here, so the big thing is that you've got these two classes of making images. You can do it with raster, where you have an electron beam that scans across the screen. And I like this pause mid drawing, where you can see that the raster image is sort of being drawn pixel by pixel in a series of lines that usually go vertically from the top down to the bottom. And so this is how most pictures are drawn on games or on systems or on the screen that you're watching this on. It's drawn in a raster sort of way, where the pixels are all filled in. And when you collect a picture from a camera, this is how it gets displayed back to you, is by drawing things in pixel by pixel. And so we can get nice full images with the little alien to look like that. And then vector, I think, is neat to see happen this way, but it sort of obscures it with all of that crazy that's going on. But if we head over to this guy, there's this game that has, let's see, if we hop into here, this game would have been an old school arcade game, right? We're talking one of the very first ones out there. And it had these nice smooth lines that you can see sort of flickering in and out of existence. And that's because instead of doing what a TV normally does, which is scraping the signal from top to bottom on one of the old TVs, it was directly drawing those shapes. So it was directing electrons from the back of the TV, from the back of the screen to the front, and directly controlling where and how it was and whether it was blinking on or off. So it could directly draw the shapes and follow those shapes without having to draw them pixel by pixel. And so the example continues on. It says, here's these smooth ones, which has got kind of a charm to it, right? As they say in the video. And then here's another example of a game that's got the same thing. So you can see sort of the smooth lines. And then here's an example of the same sort of game, but drawn in pixels, right? Where each little block is there. And I love this old school style because the pixels are so visible, right? Your resolution was 400 by 600. And so you could see every single pixel in the system. And so here's Dig Dug, right? Doing his thing. But all of those were pixelated things. Because you could get filled in shapes, raster really took over. And so, yeah, no, that's a really good question, Ruby. What is it that makes it a vector? A vector is so raster is where you just have information about each thing. And then if we click on to the next slide, let's do this. So we go on to the next slide. A vector is a piece of information. It's a number that we talk about in physics classes all the time. So in addition to teaching chemistry, I've taught a lot of physics. And so for teaching physics, you talk about vectors right up at the start of the class. And a vector is a number that has a size and a direction. And both of those things are essential parts of what's going on. And vectors for computer graphics, your size and your direction would be like, how long is this side of the square and what direction is it going in? And how long is that side of the square and what direction is it going in? That you'd say right 10, down 10, left 10, and up 10, where you'd have the direction and the size both included there in what you've got going. And so vectors let you describe sort of distances and shapes and describe the motion that's there. And so if we head back over to those graphics, right, even just like this image here, that little arrow on the front, that guy is talking all about, is just pointing out what it's able to draw. And so let me hop back over to sharing screen, stop share real briefly, and share.
Can you give a visual example of size and direction?
Yeah, that's a really good question. Let me hop over to, like, if you're dropping something, the one example that you might have remembered traumatically from high school science is that if you drop a bowling ball off the side of a building, your Galileo on the top of the Leaning Tower of Pisa, and you drop a ball, it's going to fall at 9.8 meters per second downward. And so that 9.8 is the amount and the direction is downward, and those two are tied. When normally we'll shortcut it to say gravity is 9.8 in a physics class, we mean that it's 9.8 down. And so having both of those things together is really an essential piece of what's going on in their numberhood. Vectors are actually fascinating. And if let's see, if we're in here looking at, we're right in the browser. Let me close this. We can do 3 blue, 1 brown. Nope, spelled it wrong. 3 blue, 1 brown. This guy teaches math through all sorts of things on YouTube. He's, I think, maybe a Stanford. Here's linear algebra. Linear algebra is all about vectors. And so this is, if you want to really go deep into vectors, you can do all sorts of crazy stuff like vectors. What are they even? You can totally watch these. These are mathematical vectors, which are a little bit different than the vectors that we're using in drawing vector art. So down here is Inkscape for beginners. It uses the same word, but they have a slightly different meaning. But in both cases, what you've essentially got is your number. A physics student is going to say that you've got sort of an arrow that describes the length and then also a direction. So those are the two pieces that are in play. This is the one that's been rolling around in my head for years as a science teacher, that there are there's dimensionality to this. You can describe all sorts of motion in all sorts of crazy ways if you really want to. But a mathematician can also, or a computer science person can think about them as a list of numbers. And so for us, we're going to think about them as shapes, and sort of they drew the house there from a list of numbers that might describe the geometry of that house. And so you won't need to get into those lists of numbers as we're playing with this, but you might be describing things, or you're going to be using software that's doing that at some deeper level. And so it's interesting to look at how this works and to get through all the mechanics of that. But the good news is that's not something you need to know how to do. What we do need is just an ability to look at sort of what these pieces are and how they play together, and sort of what this move is. Let's see, there's stuff coming up in the chat. Yeah, yes, 3 blue, 1 brown is huge. It's such a good channel. I would strongly recommend. So if you're curious about what's going on with all of that, you should totally watch those. But here I've got, just to like help to draw the distinction and how it's going to apply to us, I prepared these two items, these two guys right here, where on the left, this is a vector file. So this is drawing a red square that's 16 by 16. That's the entire image, 16 pixels by 16 pixels. And the inside 10 by 10 square is red. And that's it. That's all that's in it. And so here's an SVG file. And you can see that in the SVG file on line 6, it actually says its width is 10 by 10. It's going to start at position 4, 4, which puts it in the middle, and it's red. That's saying the top left corner of this little square is at pixel 4 by pixel 4. And this is totally zoomed in, so it's a little bit easier to see. This would be very small otherwise. But a vector file will describe geometry and sort of what's going on. And this is nice to see it in such a plain language sort of way. This is a shortcut that makes it more understandable. But the core of it is that that's true all the time. Here on the right, this is what a red square, a totally equal red square image. It's 16 by 16. It's 10 by 10 red in the middle. But this is it in a bitmap. And so bitmaps and other like photo or image files will often describe the color of each pixel. And so if you really drill down, and it takes some legwork to open up a file this deeply when it's an image, but here you can see this whole section where there's just F, F, F. This is all written in hex code. So F is 16 when you translate it back into decade numbers and numbers based in tens. But all of these Fs means that this is the white space. It's like that white area above it. Then the white area below the red square here is this FFF there. And you can see the sort of intermittent stripes of F. That's where it's describing the vertical stripes of white on either side of that red square. In a bitmap image or in a raster image, you need to describe the color of every single pixel in your image. And so this is all of the code that it takes to draw just this one 16 by 16 item, which is not actually a ton, right? It's just hex code and it's pretty small. If you were to get this in a PNG, it's even more compacted. A bitmap is not compressed, but a PNG is. But the SVG for the same thing is often, for a simple shape, it can be way, way smaller. And there's some like trickiness to having this be just one line of code, but essentially it boils down to one line of code as long as you've got all of the framework to understand that. And web browsers do, right? This is open in VS Code, which we use to write websites and a few other things. But you can describe simple geometry really nicely with just vectors that describe the shape of what's there. There's also other benefits to this, is that since this is readable by a browser, I could go in here and say that there's an ID to this rectangle. And so then I have an ID or a class, and then I can use JavaScript to play around with it, which is even crazier. But because vectors describe their content, they don't just give you a series of pixels. There, you have more of an ability to manipulate what's going on inside of them with an SVG. With a raster image, with pixels in an image, it's really hard for the computer to understand what's the content of it. It's part of why computer vision is so hard, is that computers don't inherently understand what's going on inside of a picture. They have to, it's only recently that we've gotten good at computer vision. Otherwise, if computers were good at seeing what was in there, we would have had computer vision a long time ago. So there's tons of these file formats, and it's good to know that the common ones are SVG and DXF. Those are the two that we're going to play around with more or most often for image vectors. But over here, you've got BMP, JPEG, PNG, RAW, the things that come out of cameras or that you see lots and lots of images with on the internet. If it's a picture, it's going to be one of these file formats. And so, oh, what's up?
Will those laser machines and the other one, will they read AI files, or do I need to convert the AI, or when I save it in Adobe Illustrator, do I have to save it as an SVG or a DXF?
That is a good question for Inkscape. And so will Inkscape open AI directly? I'm pretty sure it wants to convert it. The best way, I'm a Corel native actually, which is sort of weird. And somebody might be weighing in with exactly the answer to the question.
Thanks, Lila.
Yeah, save as an SVG. I like to save as a PDF also. That also works really well. Both of those are good exchange formats where you ditch the proprietary stuff of Adobe Illustrator. And so save as an SVG or save as a PDF, they can both work.
Okay.
So here are your design software options when you're really trying to figure out which one are you going to use and what do you go from. I'd say there are 5 major players, and then there's the one that MakeHaven uses. So yeah, and I think you're right, Ada. I don't think Illustrator writes DXF. It will read it. DXFs are going to come from 3D design software is where we're going to go with that. They're super useful to go from like I designed that dust shoe in Fusion 360, and then that will export a DXF that most every one of these vector softwares will read, but they usually don't generate those.
Right. Yeah, I noticed that I could open that up in Adobe, but it was hard to manipulate it or do anything with it.
Yeah, basically they come in and they're like not editable, which is good for what they are, but we'll get to that a little bit later. Your main options for doing vector design software is Adobe Illustrator and Affinity Designer are probably the 2 favorites. I'm a Corel oddball just because this is what I was used to. This is still, I think, not a subscription software. So you can buy it one time for like $400 and then it's yours. Adobe has a subscription model, right? And Affinity, I'm not sure how they bill. Does anybody know how Affinity bills? Yeah.
Once.
Oh, that's nice.
You buy it once.
That is my favorite software plan. Gravit, I believe, has a free tier, although I'm not sure. And then Sketch.
Affinity is also quite cheap compared to these, compared to the other ones.
Yeah.
I'm not sure how much it is on desktop, but like the iPad version of it, I think was $20, $30.
Last time I looked, I think for desktop it was not too much more. I think it was like 40.
Yeah.
Oh, that's great. So then it's probably worth it to buy that if you're really invested in this and you wanted to play around with another software.
Like I do use Illustrator for a lot of things too, but Affinity is pretty solid.
Yeah. And I really haven't gotten into it until I came to MakeHaven, but I'm increasingly impressed with Inkscape. And I say that, and I know that many of you are going to be like, you're dumb, but it can do pretty much everything that I need it to. And it does it all for free, which is absolutely got some value added. And then the other piece that's really important is that it's the direct vehicle that we use to run our machines. And so the conversion to Inkscape is a little bit tricky, but Inkscape is absolutely a useful piece, and it's totally like its own quirky little animal. And once you figure out exactly what's going on with it, you'll be totally fine. Luckily, later on in the slides, I have a whole host of videos that are linked. There's somebody who made a whole series of tutorials that go along with Inkscape and how you can use Inkscape to do pretty much anything. So even if you're used to the other ones, Inkscape could be an option for you, but there's no reason why you have to go wholesale into it if you've already are a paying customer for the others, because they're completely valid. Like there's some things I know how to do better in Corel than I know how to do in Inkscape. And so I'm like sort of straddling those two. It's pretty reasonable, I think, to live in that space. Down here, I've got a link to free Inkscape lessons and then a good discussion about Illustrator versus Inkscape, because I think those are probably the two players that people are going to be bouncing back and forth between for a few of you. Oh yeah, and a good thing about Photoshop. Many people will wonder how does Photoshop fit into this, because it's another one of the main things. Photoshop handles pretty much exclusively raster images. And so if we're just thinking about it from a file landscape, you want to think about options that can directly manipulate those vectors. And so you really are limited in scope. Not every image manipulator will let you manipulate vectors. And so you got to stick to the suite of designers for what's going on.
Can I chime in, Corey, about that?
Absolutely.
I've taken a lot of photographs and sketches I've done, taken just brought them into Illustrator, and then you can actually kind of squeeze out like vector shapes. You can get them very detailed and very fine, up to just getting kind of, yeah, exactly, like the bare image like that.
Yep.
So there's definitely, I think, a place for them.
Oh,
for Photoshop and what's the other one? The open source one that's sort of
GIMP.
like
Yes.
Yeah, GIMP.
Yeah.
I was gonna say that I primarily, in relation to like SVGs and stuff, I will use Photoshop if I'm going to be converting a bitmap, and so I'm just more comfortable like cropping and getting things into like black and white, something that's easily traceable for Inkscape. So that's how I will use Photoshop or GIMP to do that, and then move it into Inkscape. So if you don't have, even if you don't have Photoshop, that's been my experience.
Yeah, and it's totally like when you think about the tool chain of how you're going to go from one place to another with your designs, it's good to know all of your options. And this is one where I think people definitely have strong feelings about one software versus another. Although you could probably play like some weird game of tag where you go from one to the next to like convert files and use your favorite features of each one if you really wanted to. The hope, though, is that we use live trace, like Lila talked about, is in Illustrator, or there is an analogous process in Inkscape. It's just not as good. Corel has a similar thing where it will take a raster image and turn it into vectors. And sort of any one of these that's fully mature has some process to do that. Inkscape, I haven't used it, I guess, since they changed over to Inkscape 1.0. But Inkscape 1.0 may have upgrades to that process so that you have nicer versions. of that tracing software, but it's totally useful. And so we'll sort of see where that's going.
That's the
Yeah,
main thing that Affinity Designer does not have. At least the last time I tried to find that in there. Maybe someone else who's used it more recently would
yeah.
know otherwise, but I don't believe that it has any live trace or image trace capability.
Are we talking about specifically turning like JPEGs into like
Yeah,
vector?
any
Yeah.
raster stuff.
So I do that primarily on Inkscape, and I mean you can control like the quality and like the what your edges look like. I personally haven't had a problem with quality. I also haven't used any other software, so that's just my experience. But yeah, it's not like the most perfect, like, she's not that nice, but it gets the job done.
Yeah. I think that really, if I were to compare Corel, which is sort of an oddball in this game, versus Inkscape and how they trace from bitmaps to vectors, I think that probably the nicer part about Corel is that it has better dials for me to twist while I'm doing that conversion, so that I can say like be more sensitive to the grayscaling, or like use this threshold that's a little bit nicer than Inkscape's. Inkscape does it totally, but you've got to do more cleanup on either end rather than it being an automatic process. And I think that Illustrator is probably even better than Corel is at it, and it sounds like Affinity maybe can't do that or can't do it yet. And so there's that whole tool chain of what it is that you can do and like how well that particular piece works. But if you are doing, at some point, it depends on what you're designing, how often you'll want to go from a raster image to vectors like that. It's actually not something I do super often, but I'm also not nearly as artistically bent on the things that I make. So it depends on where and how you use software for which one is going to feel the most useful. If you do that constantly, you're probably going to want something that does it really nicely, whether it's Illustrator or Corel or whatever. Inkscape can totally do it, but it may not have the bells and whistles that you want as you make that transition. But it's a really important feature as we're going, and we're going to see that in just a second. That was planned for a little later. We're going to talk about it. So what are the main things that I want you to know if you're thinking about vector design? And I think probably everybody here sounds like they already know these. But the big thing that you need to know about a vector design is that it is not a photo. When I've taught this to high schoolers before, they will regularly get caught up on the idea that, oh, I've got this picture that I like, and now I want to laser cut it. And they don't ever think about the fact that in between is Corel Draw or Inkscape or Illustrator, and they need to figure out how to go from the one form to the other, where they can amplify the contrast or they can adjust what's going on so that it comes out nicely, so that you've got all of the conversions that you want to have. So the big thing is that you need to start to think about shapes. If you're going to be designing specifically in these vector softwares, don't try and do photos. Think about them as their own vector shapes. And I like this little Yoshi egg, because you can clearly see the nodes being manipulated, right? You want to think about sort of lines and connections. And as I watch that black line sort of wiggle around, I think about it being the vector, and sort of the movement of the Bezier lines set its shape, its direct orientation, and how it's going. And that's what I'm thinking about when I think about vectors, is sort of the motion of the line itself that includes both the direction for how it's going and sort of how strongly it goes in that way. So this is a big feature that it separates vector designs from the raster images, is that basically you have to consider them not photos. There's lots of things that vector designs, and I know many of you are probably already pros at this, you know that they have the crisp, clear edges. And so when you're starting to imagine what you want your vector designs to be, you're going to need to think about these clear edges. And so here on the right are great examples. You want to have strong colors and a reduced color palette. These can be really impactful if you're building branding for a website, or if you're doing, a political poster. To have nice, strong colors makes it easier to print. Makes it easier to fabricate. It means that you can build it at any scale or size. And so making things simplified and representative is really an essential part of good vector design. You can totally convert images into vectors, and that completely works. And if you're trying to engrave those colors on the laser, it's actually a really important process. But it's also really important to think about how you can take the vector shapes and do that fun like tracing tool. But then also, how would you build a design without doing that, right? Like the donut here has essentially got just a few circles going on, right? Get rid of the chocolate. You could pretty easily make a donut by a few circles and then a couple of cutouts, right? Or this is just a series of straight lines to make this little origami thing. Or the Superman logo is a relatively simple set of shapes and 2 or 3 colors. The border of Germany, this would be a good example of where I think I'd want to do a trace. You know, if you found a picture of a map, you could totally take that and use it to turn into vectors. So those are all good examples of what I think of when I'm looking at sort of vector images and vector art. It's the classic clip art that 1994 was really good at giving us all. Clip art like that is a lot of fun. It's got a lot of place in the world, and computers are, oh, maybe it is France. You're totally right. Sorry about that. I need to go to Europe is what I just learned when Corona's over. The key here is that you've got all of these different pieces to make a vector design that make them a little bit simpler. And you want to just simplify that out because really their role is something that's interesting. Here's an example of a vector design that I used with a student for a friend. A friend of mine was in charge or designed and set up a whole improv comedy festival, right? And so they wanted to have branding to go along with their festival, and a vector design for their logo was a big deal. Now, I didn't design this particular logo. Another friend did that. But this was a vector file, which meant that it could totally fit on a phone over here on the right. This is us texting back and forth about the plans. And then we printed it out on a 4-foot by 7-foot poster, right? And so because you have a vector design, that scales super well all the way up to the largest sizes. Where if you had a raster image, as you zoom in more and more and more, those pixels become more and more evident. And I'm absolutely certain we've all seen someone's images way too zoomed in, and then there's the pixels and it just looks bad. The vector is nice because you can zoom in as much as you want and it just mathematically expands because it knows the content that it's trying to describe. Every one of these little zigs and zags would have been described by some sort of a vector line. And so it gives you a nice thing. And yeah, Kate, the big takeaway from photographers, vectors do not pixelate at all. And so if you can use a vector to make your design, you can make it as big as you possibly want. Like this is 4-foot by 7-foot, but it would have looked equally good if it was 40 feet by 70 feet, right? You could have had it as big as you wanted because you've described the content that's there with lines and vectors. You're not describing the color of each pixel. And like, sure, you can get the color of pixels. That's what I'm doing up here on the right. And you can describe it with color codes, but all of that goes back to the content that's in your file. And so that geometry and its description is really important, and it lets you be able to play at multiple sizes. Also, a fun side note, logos are super expensive. They can be super expensive commissions. And so if you become a good logo designer, you can pull down 10K for a good logo. So that's absolutely an interesting side note. And the guy who does most of the tutorials that I link to in these slides, the logos by Nick, he's absolutely one of those designers that gets a whole lot of expensive commissions, I'm sure. So here he's just like hammering through YouTube tutorials about how to do all of this on Inkscape. So if you want to get happier with Inkscape, he's a great resource to watch to see sort of how these things all work. And if you want a deeper and like more a better explanation from someone who is absolutely based in this world, he's got tons of videos that'll go over it all. Let's see. Yeah, I'm 100% sure that that's hard to do. I assume you've got to be a designer with like a big reputation and a company who really wants it. Like you've got to, the stars have to align to make that happen. I've seen a few videos where they like pay different amounts for logos, Like people on Twitch who want a new logo for their channel, they'll pay like $5 and $50 and $100 and see sort of what craziness they get with different costs for logo designs. It's wild to see that happen. So like the whole dynamic of that is a little bit bonkers. And I'm so glad that that's not a thing that I have to price. Yeah, that's, it's frustrating. I'm sure undervaluing the work that it takes to make a good logo is definitely something that the world is sadly able to do. But here's another important detail is that font and letters are always vector objects because we want to be able to scale our fonts up as much as we need to or scale them down as much as we need to. Usually it's like a TIFF file, or there's certain file types that go for fonts. I know there's a lot of font happening on this slide, but fonts and letter objects are totally a vector always sort of thing. So of font or letters, these are always vectors that are always described in a way that a computer can scale up or down as much as you want, which is super important. So you can have nice, crisp, clean, readable letters and typeface. But it also makes it a little bit wonky to go with any vector design software, because if you want to edit it, you can't just deal with it as a shape. You have to deal with it as a letter. But then if you want to play around with it, you're going to need to take it from being a letter recognized object to being a path object. And so you probably have played around enough with, one of these vector design softwares you might have to know that you can take text and turn it straight into shapes so that you can play with them that way. Now, there's lots of interesting things that you can have happen once you start to describe your shapes as objects, right? Then you're doing that in a computer. And so you get all the fun benefit of a computer being the one that's describing those shapes. And so you've seen this image before, actually, because it's a nice Boolean to do with shapes, where you can say you've got a circle named B and a square named A. You can do Booleans where you say A not B or B not A. You can do unions and combine. And every one of these vector design softwares that I've played with, they all have a menu that looks something like that, where you can get things to combine or subtract, and you can have all sorts of interesting geometry that comes as a part of that. And I would encourage you, as you're trying to like get better at actually doing the design work, to start to think about your shapes that way. Like, how would you piece them together from other simpler geometry? How would you get that to work? And sort of how would you do repeating patterns, or how would you enclose shapes? Those sorts of things. Those are all really, really valuable skills to start thinking that way as you do your designs. There's also 21 Inkscape tools. Here's a video explaining all of them, which is really interesting. And then because these are objects and you can start to think of vector shapes as objects, those have locations in the files that you can identify and manipulate directly with JavaScript, which is super cool. If you have a website where you hover over text and the text changes color, that can happen where those are text objects, but you can also do that with pictures and shapes. And you've probably been on fun websites that can play around with, I apologize, just reading the chat. It sounds like people have had rough times with Fiverr. The key here is that you can manipulate these SVG objects sort of as you're going, and you can play around with them on the fly. Because you're able to control and manipulate, you can, typically what I've done with this is changed color. So like if you have an image or a graphic in the middle of a page, you can change its color when you hover over it, which is something that's kind of easy to do with text, with a hover effect, but it's a little harder with shapes or abstractions. But SVGs make that possible. You also have this node edit mode, which is super useful. If we head back over to that egg, let's see, if we go back over to this egg, the nodes are visible with these little squares, right? And you want to start to think about and pay attention to where nodes are in your vector software, because those are critical points where you're at the beginning or end of a vector. And so those are really important to think about. And the fewer you can have, usually the better it is. If you do those transfer things in Inkscape, where you go from a bitmap to a vector, you'll oftentimes get tons and tons and tons of nodes. And that's usually the best way to make Inkscape crash, is if you have too many nodes. So you want to be thinking actively about how to have the nodes that you want and not too many. Having just the right amount can really make it so that your pages and your images load faster, which can be helpful, or that your images don't have a bunch of goofy geometry that's hard to tweak. The simpler they are, the easier it is to manipulate that. And I've totally crashed Inkscape many times by doing that conversion. I think Illustrator is probably better at keeping you from hitting that limit with nodes, and Corel is fine. I've crashed it too. Um, but having the right amount of nodes and not too many can really be helpful for getting these designs to work the way that you want. Another thing that's tricky is that you want to have your shapes close, because for vectors, there's infill and then there's stroke. And we're going to see that those are the two things that you really want to pay attention to, is the line on the outside edge, and then also the infill of the shape. And so when we're just looking at A and B here, A is is the square, and B is the circle. And then B has an orange infill and a blue infill for A. The dashed stroke on them, the dashed border, is something then you can describe. And so those are sort of the two properties of your shape. It's stroke and it's infill. And so you need to think about how those work. But if your shape doesn't completely close, you can still have a stroke, but you really can't infill a shape that isn't completely closed. You have to think of them kind of like balloons, right? A balloon won't work for filling if it doesn't close completely. And so you can think about it like a cup or a balloon, but anything where if there's an opening, it's going to leak out and it won't work right. Some softwares will throw up a flag and say your vector isn't closed. Others, most of them have like a close nearby openings in the vectors. There's usually like a close the gaps button on a lot of these softwares that you could use. And then some of them don't do anything, where like you hit fill with red, let's say, on a square that's got a little gap in it, and you might get a crazy triangle that goes zooming across the middle of your shape. That's because the nodes aren't lined up, or there's maybe a small gap, and it's just trying to guess at how to close it. And so having simpler designs that you're more in control of makes for better vector designs and better vector cuts. And so all of that is important as we're thinking about vectors, as we start to understand them as toolpaths, because that's the next step of where we're going, is how do you simplify all of that, and how do you use them for actually making things? And so there's lots of different ways that you can use vectors to try and move what you're building forward. So the first thing that I want to do is make sure that we've got a term, because I'm going to use it a fair amount, which is WYSIWYG. And so I love this term just because it's fun to say, honestly. Things that are WYSIWYG are what you see is what you get. It's just an acronym. Microsoft Word is a great example. When you think about software and like how software works, some things are built to be WYSIWYG, and it turns out vector software is not. But Microsoft Word had to be, and it was one of the very, very first things. Oh, let's see. Can anyone hear me? Oh, gotcha. All right. So we're going to keep going. Hopefully, Holly, you get the audio figured out. But with this, a WYSIWYG software, what you see is what you get. So when you write up a Word document, and you hit print, it'll print exactly how it looks on screen. And that was super important when they were first envisioning computers and how would you write a paper on a computer. You needed to make sure that the people who had never used a computer before, because they didn't exist before, that they understood how to use it. And so making your software as WYSIWYG as possible was really valuable. And so people who, everybody, like my grandfather could easily use Microsoft Word, and he was definitely born well before computers, and ended he ended working before they showed up in the workplace. But he was able to do this without much tech savvy at all. And so WYSIWYG software is really, really helpful. But vector design is not WYSIWYG. It's not what you see is what you get. And so there's some trickiness, especially when you start to think about your vectors as toolpaths, where your vector design for artistic purposes is going to be different than vector design for tooling purposes. And so that's a really important distinction, where we're going to stay focused more on the tooling side, because this has implications and it affects how things get made, and then sort of the dynamic between you, the software, and the tool. So there's some quirkiness to this that I've got an example for. This is the coat of arms for Russia's atomic city, where Russia's nuclear program was. And so I had a few students who were of Russian descent. They absolutely loved this logo. We just like randomly found it one day during a class, and like, I want to make that, because they just thought it was so cool. And so they selected the thing, they highlighted it, they made every line a hairline, and then they hit cut. And so when they cut it, unbeknownst to them, these ovals actually extend behind the bear sort of like is shown here. I just took those ovals and brought them to the front. And when they did that, it cut the bear into pieces, right? So when they made that cut, it totally broke it up from what they thought they were going to get. Yeah, it's actually a fantastic logo. But what this means is that what they saw at first, this logo here on the left, where the bear is ripping apart the nucleus, this guy is not what it ended up being. It ended up cutting the edge of every vector that was described, not necessarily because it was visible, but just because it was there. And so you've got this interesting dynamic where vector design software is describing those lines, but the lines that it describes aren't necessarily the ones that you can see. And so it means there's a few like pieces that go along with this, a few story points to pull from what's going on. And so yeah, it's definitely not the Build-A-Bear. The key with this is that you've got to think about how do you clip your vectors? And so how do you extend or don't extend your shapes, right? How do you keep it so that it is as WYSIWYG as you want it to be, right? You need to think about, do you have to cut those overlapping ellipses so that they don't cut anything up or slice it into pieces? You want to think about how are you going to manipulate something and what pieces and parts are there. If you find something, you don't necessarily know what's going on. Whereas if you design it, you can have that in mind, that you want to only have the vectors that you need to make the cuts that you want. And then you also want to be thinking actively about infills and hairlines and sort of how that's going to be cut on your machine. In the laser and vinyl cutter that I was most used to at the school where I taught before, the laser cutter would only cut if you had a hairline, but the vinyl cutter would cut the edge of every infill and it would cut all the hairlines. And if you had a thickness to your stroke, it would also cut both sides of the stroke. So you could get a cut up to 3 times in the same exact location, depending on the particular print settings of what you're dealing with. And so this is something that, like, it may feel subtle, but it's totally something that you can take into account so that you get the most deliberate results that you want to. And so this is totally something that you want to think about as you're moving forward and as you're looking at your designs and how you want to cut them, is planning where exactly you want your cut lines to be, where do you want hairlines to be, and where do you just want an infill of a certain color. So all of those pieces you want to take into mind as you're designing what it is you want to make. And so if you want this to become your new holiday ornament that you're giving to people, which is totally a valid thing to want to do, you'll want to think about how would you crop these lines and pieces so that it turns out the way you want. So there's a whole bunch of things that this means. Like, there's this list that I would recommend you just come back and look at. There's no way that these are all going to sink in one shot. But I would say if you're thinking about vectors as tool paths, which is different than vector design for generally coming up with good shapes, you want everything on a single layer just so you can keep track of it all, rather than having layers in your documents. A really good, like, Illustrator's great at having multiple layers inside the same image so that you can make sense of it all and stay organized in the design phase. But I'd say flatten that. Bring it all down to one single layer and clip your shapes rather than overlap them so that you don't accidentally have vectors like those ovals that go behind the bear. You want to also think about using the RGB color space. Sometimes there's other settings that you can use, like CMYK is the settings for printing for cyan, yellow, magenta, and black in K. Those are really useful if you're going to use the large format printer. But for laser cutting, I think you really need to have RGB. Let's see, is somebody unmuted? Got something to add in? No? Okay. Another thing that you really want to think about is how do you want you to plan your colors?
Corey, I did have a question. So let's say we didn't clip and we had overlapped images, but we didn't necessarily have an outline. It was just all fill. Would the same thing happen?
It should not then, because it would just raster the fill. But all of those become conscious choices instead of I found this cool thing and then hit print. Right. And so you can totally manipulate that and be in charge, however it is that makes sense for you in the particular image that you're looking at. You just have to actively be thinking about it and managing.
Okay.
Yep. So you want to think ahead about colors and settings. One thing that I've really picked up over the past year or two is that the colors that my image is, especially if I'm using the laser, they don't have to be the real color of what I want it to be. They need to be set up for the setting that I want to have. So like if I want something to be like gray and slightly darker gray when I'm doing a raster image on the laser, like burning things in, I might have it be purple and yellow, not because it's going to be purple and yellow or because it was purple and yellow, but because they're full RGB colors, right? For yellow, I want to have green and red turned all the way up. And for purple, I want red and blue turned all the way up. And I can clearly denote those when I set the settings, even though it's not representative of what's going on. So sort of playing with your colors in a shape so that you can control the settings for when you go to make it is really important. I wanted to find, but I couldn't find a good example. I had lots of students who wanted to cut SpongeBob all the time. And SpongeBob is a lovely character, very, very like appealing for vector cutting for raster cutting on the laser. But what you often need to do is take SpongeBob's like very subtle colors and sort of amplify them in weird ways that wouldn't make sense if you could show him in color. You have to think about SpongeBob in black and white and how would you contrast him the right way to get dark parts next to light parts so that you can make out the tie versus the shirt and the pants and all of those things while you're doing the burning process. Kate, you really have got a lovely army going on right there. Let's see. Another thing that you want to do is convert your text to curves before you make any cuts. That can be super helpful so that you're cutting the edges of text out. And then objects to vector paths is a key move. That's something that when you get your badge, object to path is going to be the most important button that you forget to hit while you're using the laser. Object to path will take your objects that you've designed and turn them into tool paths. Minimizing your nodes can often make cuts like easier to process. They're less data, but they often go faster if there's less nodes because sometimes the cutters will pause at a node just briefly. So the fewer nodes you have, the faster they'll cut also. And then typically I try to avoid any double cuts just because you don't want to have the laser burning the same thing multiple times, or especially the vinyl cutter. If it passes the knife past the same area twice, you can totally get out. You can totally have issues as that comes together. Ooh, good call, Kate. Use outline view to confirm the object that you've pathed. That's totally a good check just to see what you're doing. But here are some examples from the laser. So I've sort of talked about the laser and how it works and sort of what that looks like. But these are raster and vector things that have been cut out on the laser. And so there's a few things to talk about. And we're going to go sort of a deep dive into the science of the laser next week also. But here I've got in the center sort of an old and a new laser lens. And so laser lenses take a laser beam and they bring it to a focal point. And that focal point is where the magic happens, where whatever the laser is going to do to the material, that's where it happens, is right at the focal point. And so sort of an image here, if the laser were coming in from the left, it hits the lens and it's going to cross through a point right there, a point in space. And you want that point in space to be right at the surface of what you're cutting, typically. An old laser here, it had sort of a buildup inside the glass, which happens over time. I think this was a 2-year-old lens, which is kind of amazing. But the older lens was absorbing some of the light that passed through. So not all of the laser's strength was making it to the material you were cutting, and it was degrading how strong it was. So the settings needed to be amped up pretty significantly to get the same performance out of the laser on the old side. On the new side, it was a brand new lens, so you didn't have any of that stuff going on where the energy was being absorbed by the glass in the lens itself. And so you can see it's a lot darker, and even I lit some of it on fire down here at the bottom, but it was out of focus. I bought a lens that was a little bit off. It was off by 12 millimeters by about 1/2 inch. And so it was out of focus as it cut. And so you can see it's sort of blurry on the edge of new, whereas nice and crisp on the edge of old. So I had to buy another new lens when I was doing this maintenance on a laser. This was new 1. I had a new 2 that came later. But the core here is that you've got this sort of dynamic that's interesting about how a laser works and like what are the mechanisms of it happening. Those are all important things to take into account while you're doing your design, is sort of the mechanism of how the tooling actually does the cutting. And so when I'm doing a design, like here's last year's Christmas ornament that we gave out to the family in Michigan. The design here is pretty simple. It's the state of Michigan, right? And then it has just the circle that it's cut out from, and then a few other cutouts, right? In this design, I basically have two colors. I have burned or not burned. The circle has been burned to give it a darkness, right? So that it's got a little bit of contrast. And then the letter is the same deal. But I had to be really careful about how these vectors came together, right? I did a capture of a map of Michigan so that I could turn that into a vector shape. But then I had to clip that vector up here so that it didn't do any vector cutting up across the top of the state. And I had to do the same thing down over here and across the bottom and up along here. I had to remove those vectors very strategically so that I didn't get cuts along those locations. I just wanted it to be an infill on one side and not an infill on the other. So you have to be sort of strategic with how you build out your designs when you're thinking about how do you want to make them work, right? And so if you're very careful and deliberate with those plans, and usually that goes with nicer, simpler designs, you can get this sort of a dynamic where you have a look that's there and careful, and you're very strategically cutting or removing or burning exactly where you want to. One thing I've also started to really enjoy is to burn just the edge on a lighter setting, to just do a simple vector cut right along the edge of a rastered area. So you get a nice crisp edge to it that sort of relieves it or cuts it down just a hair. Can be really helpful. But there's lots of places where having vector designs can be really helpful, or where you use multiple materials. Like this is a wood piece that then had a felt piece cut on top of it and a little circle cut here with like some metal thing I bought at Michael's or Joann Fabrics that I just glued in place. And this is a tablet holder on the right. So that was a good gift. That's a nice way to win some cheap points with your soon-to-be mother-in-law, is to make her one of those. And so those are great laser projects, right? Where you can totally do stuff like that, where you cut multiple materials in the laser. If they're all laserable, you can just sort of glue them together. And the goofy shape means that it's easy to line them up. But with the laser, you can do lots of other things. Like here's cutting cardboard for prototypes. The stool eventually got made, and it's the stool because it was small and cheap. The stool eventually got made. Oh, good call. The stool is something that quickly got made out of plywood from this model in cardboard. So that's totally useful. And then if you're really strategic about your cuts, you can actually bend plywood. You can do some kerf bending with the laser, which is tons of fun. And you maintain all your strength in one dimension, but not the other. So that's a neat trick that you can pull also. And for the laser, there's sort of this balance. And I know we're on a time crunch. We're in a balance between power, speed, and PPI. These are your three settings for the laser, where power is sort of the percent of full blast from the laser tube, which is buried down in the bottom of the laser machine. If you're ever curious, it's down below where the bed is on the backhand side. Then there's the speed for how fast does it go around, and then pulses per inch. The lasers that you have in laser cutters are pulsing lasers. They're not continuous power. Well, maybe continuous if it's about 1,000 PPI, but they're pulsing so that you get little bursts of energy. And so you can imagine a laser tube down at the middle. They're bouncing it on and off super fast. And then the power is sort of like how much current are you pumping through it, or how much voltage are you applying? And this dynamic is sort of like a DSLR, where you've got f-stop and ISO and aperture, right? Those are the three: f-stop and ISO and some other third one that I'm forgetting. But I think about the dynamic between these three sort of like shutter speed. You're totally right. I knew you were going to know it, Jamie. The key here is that you've got those three things that you're bringing in so that you get exactly the settings that you want. Sort of like on a camera, you're going to adjust those three settings to get exactly the picture that you want. The guide table that we have on the website is a great place to start. And if you're really unsure about what to do with that, stick with the guide table. But as you get better, you'll think about, well, what if I do this in 2 passes to minimize the smoke? Or how do I adjust this based on the particular type of wood that I have that you're trying to cut? So those are all interesting dynamics that you can go deeper with if you want to, as you work with the laser more and more. For the vinyl cutter, there's a few really cool tricks. And so these are really important things that as soon as these become parts of your language with the vinyl cutter, they're really helpful. One of which is to think about how you want to structure multiple colored stickers out of the vinyl cutter. And single color stickers are great, but I figure we maybe don't even need a slide about that. The vinyl cutter will cut out any shape that you want, and it does a really nice job. You can use masking to pick it up and put it down. But multiple color stickers can be really fascinating to put together. I love this Homer sticker because they used this, the person who put this together, they used 5 colors to make a really nice detailed Homer sticker. I would love a different color for the mouth, but it's all we had. But those I would say are coplanar spaced layers to a sticker, that they're on the same layer, they're on the same flatness of the Chromebook, but they have different colors that are all sort of aligned together. And by keeping them spaced out just a little bit, you don't run into the problem that you can have where they like are coplanar adjacent and they just barely overlap. Then they look really bad if the edges touch and like one of them curves up, because vinyl's so shiny. Like the Green Lantern one over here was sort of on the edge of the Chromebook where it curved down. And so you can totally see that really clearly, even though it's a super subtle curve that you can't really see on the body of the Chromebook much at all. And so thinking about how do you carefully and artfully arrange your stickers is really helpful. The one thing I did really like about this sticker is that it's a stacked layer. So they kept the background is just one complete black circle that then they could place the green on top of. And so because the black is unbroken, the green lays on top of it really nicely and plainly. So you can totally do that. And thinking about how you want to strategically align them is important. If you want that ridge where the stickers are kind of overlapping, that can be a look you want to go for, but you want to be careful about it. So don't like do that willy-nilly. Think about how you want to space these out, and do you want to risk that they could touch and overlap is a good thing to think about as you're trying to go through your designs. And then the water jet is our third item. So we're going to try and hit this really quickly. Essentially, the important thing is that the water jet is basically the same as the other two. And so the water jet is really ultimately still just a vector cutter. And so it uses proprietary software. It inputs vector files and outputs outputs these cuts. But it's essentially the exact same thing. So it's really like you're not learning a new skill. But at the same time, you've got these weird softwares that you have to learn. And so that is a new skill. But the concept for what you're cutting when you're doing your design work is basically the same. This is a metal plate for that dust shoe that's got a few places where I would bend it built in here. And so what's really nice about the water jet is that you can cut essentially anything at all. Sheet metal, thick metal, stone, maybe not wine bottles, but you can cut all sorts of crazy things. And so there's lots and lots and lots of options for how you can possibly make stuff. There's tons of good things out there. Let's see, I'm trying to open up. Kate has got, we're gonna hit save. Yes, dude. Where's that going? Just put it there. Save. Boom. Is it? Oh man, that's a good layered vinyl sticker. That's really good. How many layers is that? That's red, yellow, pink, purple, black, green, light blue, white. That's a lot of layers.
That was one of the UNH students. I loved it.
Oh
She
man,
had never used the vinyl cutter or any of the software before. So.
That's so good. And like, I have so many questions about how long that took her just to get all the shapes, to get all the textures, or if she printed onto one of the brand new features that's super exciting is that you could print on the large format printer onto vinyl and then use that to cut on the next thing. That's a topic for next week. I'm going to try and figure that out this week so that we can talk about it a little bit more. It's totally an advanced skill. How do you can print on the large format printer and then hop over to the vinyl cutter to cut out printed things, which would be really cool also. But that multi-layer sticker is just beautiful. And knowing how much work that is, I really appreciate it. But back to the water jet. The water jet is essentially the same exact skill as all of the rest of the other two. It's just the cost is a little bit higher. You have to pay for the garnet. You have to pay for the power consumption on the water jet. And if you break the nozzle, you have to pay for that also, which is hopefully not going to happen, fingers crossed. But it is potentially a thing that could go on. So you have to keep all that in mind. It's totally why I would recommend you do it when there's a facilitator around, somebody who's got a lot of experience with it. Absolutely. Yeah. Hopefully you get one that will water jet exactly how you want for the wine bottle. Those are really important. I think it's important to have those little tests where you really want to find the dynamic of how it's going to work. Like how could you fill it with something that would absorb some of that energy before it blasts into the other side? But here we go. Here are our next steps, and this is going to be the end because we're sort of at it for time. The things for this week are to get badged, design something in your vector software of choice, and then cut something on the laser, vinyl cutter, or whatever machine you haven't mastered already. And so I would recommend, just if you're trying to do a few things, I put on the web page for this week a few other examples that you could try, but I would say try and raster something on the laser that's 1 inch by 1 inch. If you get larger than that, they take a long time. And I don't want you to like unexpectedly try and raster something that's 12 inches by 12 inches and then be stuck there for 2 hours. If you stick to something small, or like a 4 inch by 4 inch ornament, you're talking 15 minutes. As it gets bigger and bigger, it's going to take longer and longer and longer. I have seen 3-hour cuts before. Hopefully that's not you, but it's totally a thing that can happen. And then, yeah, a 3-inch ornament took 10 minutes each. That's about what I've seen. So you want to make sure that you're thinking about how long a laser job takes. Generally, it's one of the fastest ways to make things, but if you're rastering, that can totally undercut the fact that it's one of the fastest machines. So we're going to talk about how to strategize and how to raster or how to vector etch next week. So how, like, when you would see sort of hash marks to give shading on an image, that's something that you can totally do with the laser, but that's a little bit more complicated. But I would say if you can this week, try and get a little raster on the laser, a small vector cut on the laser, and a small simple sticker, you're totally headed in the right direction. We're going to get more advanced, more complicated with those things next week. And so you can go further. If you're already a pro, try to get more advanced with these. It's really fun to see what sort of crazy things people make. And so there's tons of options. Here are 4 videos. I think if I don't click a certain button, it'll try and play all 4 of these, but these could be really helpful. Common mistakes for new Inkscape users, converting PNG to SVG, sort of how you do that. Inkscape in general explained, and 10 hidden secrets inside of Inkscape. This is all from the Logos by Nick, who's actually really good at explaining these things. And it's really good to watch it at double speed. So these are super helpful tutorials that can really get you to a place where you need to go. Oh no, don't watch them all. Okay. And then here's the last one. Anna brought this up to me. Risograph printing is something we can't do at MakeHaven, but it's totally a cool application of vector design where you have these lovely prints. These come off of old Xerox style printers. There's apparently a spot in New York. And so if you get good at vector design, you can totally play around with this. Let's see. And then the last bit, good call. Where are the slides on the page? So foundations, oops. Units, let's go into here. We're going to hop into 2D design and making. And so if we're trying to see where these goes, risograph printing is really cool. It's a neat process, but we can't do it. So hopefully one day we can. Ooh, it didn't post. Okay, hold on a second. I need to publish a page. I made an edit and then I didn't hit publish. This is a good moment to remind everybody, don't forget that as you're working, hopefully you're doing some updating on the websites, right? And that takes deliberate effort. Here I am trying to update my website. And it definitely takes some energy. So if we go to view publish site, you want to take all those pictures that you're taking, slides for unit 7.1. These slides are right here, and this is the published version of them so that you can click through and watch all the videos that didn't have sound for us. So you can totally do all of that if you want to. They're right underneath where it says unit 7.1. The slides for unit 7.1 are right here. There's several other videos and things that was totally my bad. I did not publish it, but now it should be there. So there's lots of interesting things that we can take a look at. There's lots of things that might have happened over the past 2 weeks. Like I want to hear what fun Arduino projects have happened or what you've been up to. How's everybody doing? What's going on in life? And yeah. So at this point, I would say we're done with the official first round discussions on vectors. And clearly you guys know, you all know a lot about it already. So I'm excited to see sort of what spills out after this first week. But what happened over the last 2 weeks is really good for us to talk about also. So anybody want to go first? Share an exciting, I'm going to stop sharing my screen. And anybody want to share an exciting success or maybe something that didn't go super well that we can all talk about and cheer for or troubleshoot? Let's see. I'll also plop that link into the chat. And I know there's not, let's see who's unmuted. I can hop into there. Jamie, you're unmuted. You want to go first?
Oh, okay. Sure. I'm still working on my car alarm. I've added the motion sensor, and I added some pins to it. I soldered some pins to it so that I can hook up a photoresistor to it so that this only works in the dark, because I have a light sensor that will beep if someone opens the van door or if light comes in. I want something that detects motion, but maybe, not enough lights in there. So I want something that could also work in the dark. What else? I have some touch mechanisms, just using what are these called? Ball switches, where
Oh
you
yeah, the tilt
yeah,
switches.
tilt switches. And I soldered together a pressure sensor that was left on the table because my temperature module broke. But these ones are like really expensive and very accurate. So I played around with the coding with that. It's a little strange, but I messed around with it. And what else did I do? I soldered together an AVR programmer, but I have yet to learn how to use it. So that's something Corey and I will do.
Yeah.
And what else? Yeah, I just kind of went back over the stuff just the basics. And I played around with interrupts and just played around with new ways of coding. And that's what I did.
Cool. That's really neat. You're like diving full head first into the inputs and outputs that go along with Arduino, which I think is totally the right move for you because you had some Arduino experience to start with. One like cool note that I think you're really going to enjoy is that little thing that you held up for the motion sensor is actually a PIR sensor, which means that it looks in the infrared. So if you had some infrared LEDs, you could light up the inside of your van with infrared LEDs that you wouldn't be able to see, and the person that the sensor is checking for wouldn't be able to see, but it would still be able to sense their movement, which is exactly how the like theft alarm things on the sides of houses or like the garage sensors work. They have, and if you've ever like looked at one of those up on someone's garage, sometimes you look at it and it's like slightly mildly purplish or pinkish, like a really faint glow is coming. It's because the LEDs are glowing mostly in the infrared, but you can kind of see if they're not totally in the infrared. So you see a pinkish, but that light, you could just flood the van with that, and then it would pick up any motion at all, as long as it's lit up by infrared light. And you would never know that those lights are on.
We got to talk more about that.
Yeah. It's a neat trick.
Cool.
Let's see. We've got Kate just left, so I guess Kate's not going next. Aaron, Ruby, Lila, anybody want to go for it? Aaron, you're unmuted, but I don't think I can
There we
hear
go.
you.
Yeah, okay. That was my headset. I was double muted. Yeah, so I basically took, here, I'll go grab it real quick. It's right here. I really wanted to mess around with humidity. I'm really susceptible to just waking up with dry eyes, dry mouth, dry everything. And I wanted to create essentially a little readout for humidity and temperature that would allow me to like know what the humidity is or temperature in a given space at any given point in time. And this is like a step in the right direction. What I'm going to do next is use like a Wi-Fi board and Node MCU unit, connect it to a sensor like this, and then be able to wirelessly transmit and store temperature and humidity information over time. So what I'm going to do then is hook that up to my Home Assistant and then have it automatically turn my humidifiers on and off as the humidity changes in my apartment over time, and depending on what my plants need and whether or not I'm present in my apartment. So like I'm trying to sort of make it part of a larger system because that'll help me use it more. And I've been sort of preparing by cleaning up my Home Assistant quite a bit. So I'm really excited. It's been a lot of work. I've been working on it for a really long time, but having the Arduino experience and being able to bring that to the table, I mean, like, you know, world's your oyster if you can play around with a bunch of sensors. So
Yeah, what was really cool was when we were talking about that sensor is that there's like a whole library that exists out there, so that you may not like need to know the exact mechanism of how do you go from Arduino coding all the way to your home assistant, that somebody worked out all of that, and it's like a library that you can just
right,
tap right into.
right, it's true. That's a really good point.
That's I don't mean to lessen the accomplishment, because it's completely a really cool project, but it's neat to know in terms of keeping everybody not afraid to try stuff like that also, is that there's almost always resources that exist out there, especially if it is such a good opportunity. There's usually some background that you can hop into and find somebody else's work as a springboard, especially in Arduino. There's tons of openness to that. The libraries are really great for making all that happen. And then it's your creativity of how do you tweak that for your situation. So like your sensor and your humidity sensitivity is going to be totally different than what that library was doing originally, which was just connecting the ESP to the Home Assistant, right?
Right. Yeah.
So then like all of the rest of it is completely you.
Yeah.
Which is awesome.
I don't know if I've shown off the Home Assistant at any point. It's pretty easy to do. If anyone is ever interested in seeing it, I'd be happy to show you. I know I've showed it to Corey before, but it just didn't work. Now it works. So I promise there's something interesting to see there. Today I managed to hook it up to my thermostat and a couple of other things. So
that's awesome.
Yep.
Yeah. There's tons of cool options. If you want to try and do a screen share, that'd be, yeah. And Kate's looking
I could do it right now and just take a minute or two if that's of
I'd like to
interest.
see it.
Okay, cool. So I've been just like generally finding a bunch of things that I need to do, like cleaning things up, and spring cleaning is starting a little bit earlier this year, I guess. So anyway, yeah, here is my Home Assistant. This is an open source platform that anyone can access. It comes in this sort of like simple thing. You can install it on a wide variety of different pieces of hardware. I have it on a Raspberry Pi right now. And there's just a bunch of modules that you can download. It's all open source. And I have like a simple set of cards. These are called cards that I can use to monitor things. So I have like a large stack of hard drives that I use for storing a wide variety of things, and I can, see that right now I'm actually I'm ripping some DVDs to that hard drive, and I can see that happening right now, which is cool. I can also tell when I'm home. This is actually really useful. Like, so me being connected to my Wi-Fi router allows me to trigger a bunch of things. So one of the most fun is that whenever I walk into my apartment and my phone connects to my Wi-Fi, I get walk-on music, like theme music whenever I enter my apartment, right? And I'm utilizing, there's a bunch of awesome features, so no need to like really code. You can create these flow diagrams right in the system that allow you to sort of connect things together. So, if I'm home and it's a reasonable time of day, I can have Alexa say things to me and then play me a song, right? If I'm not home and my partner is home, then there's different options that I can do in terms of turning on lights and getting things running the way that I want. So also you can do all manner of things in terms of I don't even need to worry about turning off my lights anymore. When I leave, all my lights shut off, which is really, really great. And when I come home, all my lights turn back on. So also starting up my robot vacuum is really, really easy. It'll just happen automatically. And I created this little app here where I can, so if I don't know like where my vacuum is, I can click this button. I don't know if you heard that or not.
Yeah.
So that's pretty cool. And in terms of like monitoring all of these different pieces of information that you see are sensors that can be used to trigger other things. So this allows you to essentially like bring a bunch of pieces of tech together that weren't necessarily supposed to communicate with one another. So there's a lot of value in that, particularly when like I'm not crazy about the idea of relying on just Google or just Alexa or whatever. This allows me to sort of get outside of that. So yeah, there's definitely a lot of cool stuff that I can do with this, and it's been like a good hobby for me for quite some time. So
Yeah, and it's totally a major opportunity to be able to connect Arduino to that, so that instead of you
Totally.
having time-based things or connected to Wi-Fi or not based things, you can have direct sensors
right,
to say like, oh, it's to everybody has a temperature sensor in their house. They have a thermostat.
right.
If you've got a furnace, but then you've got you can check humidity and then turn on a humidifier or all sorts of other things based on exactly what you want, which
I
is
think it
really
makes it more accessible too, like with Arduino, not just for the flexibility, but like the cost. Like
Mm.
you could easily recreate a lot of these things. Probably, maybe it's not as like finely packaged, like a fancy Philips Hue light bulb, but you could like definitely recreate a lot of the functionality at a much smaller cost. So
yeah, and make more custom solutions. Sometimes you need a thing that doesn't quite exist or be stupid expensive to buy,
right.
but you can recreate with an LED strip and an Arduino, right? So there's tons of options that
And with
extend.
relays, you can use more fancy and sophisticated stuff. I mean, just to turn it on and off.
Mhm.
I did like a whole thing where I set up an irrigation system for my plants. These are not, so I actually have a lemon tree and a jasmine and stephanotis, but these are not actual photos of them. But like I used to have a system that would be like, okay, if the moisture level drops to a certain level, kick on an aquarium pump in a bucket and stop after 5 seconds. And that was really cool, but it like took all the joy out of gardening. And one morning I woke up to like 3 gallons of water all over my floor. So I was like, yeah, this doesn't actually, that was just my COVID brain. Anyway, I've said quite a bit. If anyone has any other questions or you ever want to take a stab at it, if I can help, please let me know. So
Yeah, there's tons of cool stuff there. All right, let's see who's next. Ruby, you unmuted. Would you want to go?
Yeah. Hi. I took these past few weeks to just study Arduino and what it is, and it took me that much time to understand like the 10 things that Corey put in the foundations page. I'm feeling really excited. I feel like I'm ready to move forward with maybe even like a little project. Sorry, my eye is like attacking me. A local healthcare center invited me to submit an art proposal for one of their or any of their I don't know what it's called. I'm sorry. There's sections. There's behavioral health. There's pediatrics. There's general adult health and things like that. And so I made a cloud lamp a few weeks ago, as you remember, and I'm thinking, what I would like to propose to them is using Arduino, have this cloud lamp flicker like thunder or fade in and out for their pediatrics. Initially, I wanted it to be something interactive for, children and young people to be able to whatever. But with COVID, that's not really going to be a thing anymore, I think. So I think this is the next best thing. And so right now I am thinking about what type of, or how I would approach that code. So I would have an array, right? And I would also have a fade. And I would also I'm thinking about how long this lasts. Does it last throughout the night or whatever? Very early stages. But I think even without a prototype, I can, submit this idea to them. I think they'll love it. But that is where I'm at. And I'm laser cutting something right now. And I can show you, but it's whatever.
Yeah, that'd be fun. Walk over and
Oh.
show us the laser running if you can.
Okay, yeah. It's okay.
And Ruby, I've been thinking about that. I talked to you yesterday about that art project and it seems really cool. I was thinking about writing up objects for some code to try and help make that all happen, because there's tons of interesting ways to make those things go, and so it'd be really cool to see sort of what your artistic vision was, and then how you translate that into code is complicated, but it's good to like have some discussions and go back and forth. So there's tons of options.
I am definitely going to approach this, and I don't feel intimidated, and I'm excited about that.
That's exciting.
So I'm running a test on this laser cut right now. They're a set of coasters for my best friend that's a huge nerd, possibly the biggest nerd I have ever met. Anyways, it's this little anime character from that Super Smash Bros. Melee game. And I don't know if you can see it.
Oh, those look really good.
It's pretty deep, which I knew already, but I sort of am familiar with how deep the laser cuts when it's on the preset settings that MakeHaven gives you. So it's just, just giving me a general idea of like the ballpark. Do I need to lessen power and stuff? Because I didn't really want to guess, which I usually do because I'm just reckless. I'm a reckless person, but this is giving me a better idea of all that. Anyways, that is what I'm up to. Oh, and if anybody needs any help with Inkscape at all with the laser, I'm here.
That's awesome. Yeah, that's really cool. It's good to see the raster happening, and it's like that's the raster action on the laser, in case you haven't seen it, where it goes back and forth, scraping out each little line as it goes, burning away the wood, and you're totally a rock star at getting that exactly right. So that's awesome. And completely, Ruby's going to be probably more helpful than I am with Inkscape. I'm getting better, but Ruby is a pro for sure. All right, let's see. Lila, Kate, or Anna, anybody want to have things to share?
I'll go.
Yeah.
Can you hear me? Yeah.
Yep.
So I honestly didn't do too much with the Arduino. I moved. Big life change.
Yeah.
Still kind of having a lot of anxiety and diarrhea about it, but okay. So what I have done, I went on Linda, which is like my best friend, and I went through some of the Arduino stuff on there. And the other day I finally caved in and I bought myself a little kit that has the little sensors, because when I saw what Jamie and Aaron were doing and making all that stuff, I said I wanted to kind of do that too. And so I haven't gotten to that point, but I've watched the videos and I get it. But at the same time, I can't really think of something I can use this for practically. Whereas like the other things that we went over, I could think of projects to do with it. So I think for this one, I'm just going to kind of go through the motions and kind of learn what I could do with it instead of actually applying it to a project.
Yeah, there's actually a ton of value, and it seems silly, but like to build something that's kind of useless is a really good way to learn. So I would recommend you just like grab bag. Here's a sensor, here's an output.
Yeah.
This sensor is going to be mapped to this output. So
yeah. So just kind of gonna play with it, and I don't know if I'm actually gonna use it in the future, but just learning along and going along with it.
Yeah, that's awesome. That's exactly what the first Arduino projects are never like the most productive projects unless you've been stewing on them for a long time. I think that you can find good examples and say like, I want to make that. And then when we get to inputs and outputs, it might start to make more sense. But yeah, so I like the put a pug on it option.
I feel like if I could somehow make it a project about the pug, I can like think of something stupid instantly that could apply it to. That's when like becomes handy.
I saw a really good video about somebody who made like a button so that a dog could give itself a treat. What if you did that?
Oh.
So like he had a big button that he could stand on, and if he did, it would give him it would like spill out a treat or like open a little door and there'd be a treat for him.
They have those Furbo cameras. Have you seen those? It's kind of like a home monitor, and I guess you can shove treats in it, and if you're at home, you can watch them, and it will spit a treat at it.
Oh, but you could
If
make
you
your
ever
own
go
one.
somewhere where your dog isn't again, you can like remotely treat them.
So maybe I could make something like that.
Yeah, you totally could.
Do you give your dogs treats when it barks?
I don't want to encourage the barking.
We had a MakeHaven member who designed a dog bowl sensor that would send an alert to his phone when like the water bowl was empty, which I thought was pretty cool.
Oh, that's actually great.
Yeah.
I don't know if this is interesting to you at all, but it has to do with alternative communication. There are, I want to say up till now, like 3 different people who are using the same techniques of applied alternative communication to get their animals to hit buttons that tell like that coordinate with a specific ask or concept. So there's a dog that has a whole like array of buttons,
And it knows what button does what.
and it will say it will hit like outside play mom, or it'll be like mom food now. It has like a now and a later button. And then there's someone else who's attempting to do this with their cat to see if it works with the cats to less successful results.
Yeah.
But you could make it so that you have a reward system connected to those buttons with Arduino. Like the Arduino is the input and like can register the input of the buttons. There's a couple of videos I will put links to in the chat that I've been watching.
Yeah.
When I eventually get my rats, I want to teach them how to do this on a smaller level. So I've been watching a lot of these videos. But I thought that might be interesting because instead of encouraging him barking, you could actually maybe get him to communicate with you in a way that you both understand.
I like that. Cool. Yeah, cool. Yeah, so that's really my update. I'm going to turn this over to, you want to finish this since you were just talking?
I'm amazed that the dogs would hit the later buttons, like that they would communicate that.
No, everything's
I agree.
Yeah, like I cannot imagine any of the dogs that I've ever had in my life hitting the later button.
What if it was for a bath?
They know. They'd hit a no button.
Yep.
I don't even like see dogs as having a concept of later. They're just so in it.
Yeah, it would just be like food now.
Oh my god.
Ball now, ball food.
Yep.
I mean, like
a cat maybe, but
to what extent do
no.
dogs have a consciousness of like of time, you know?
Yeah. Time is a
and like
complicated
and like
one.
the future.
Mm-hmm.
You know,
The
maybe not how
dog-
long something has been, but like a forward-looking consciousness.
I guess they'll know if you're coming home, right? They kind of do.
But sometimes that's like smell, or they hear you,
Yeah.
or like they like that it's a certain time of day, but I'm not sure that they like know that time of day is going to come. It's
I
just
think they
that
do.
it does come.
What
I
if
love
we
the thing about
accidentally?
The dog that Leanna's talking about, the TikTok dog, his name is Bunny. He started to understand that, like, because he asked, "Who is that in the mirror?" Basically, and then he freaked out.
How did he form that that idea?
Because he was
though?
like stranger, like there, like, oh my god, I'm gonna find the video and I'll throw it on there. But it's crazy. It's crazy how big of a brain this dog has. Like, oh my god, look, I finished.
Oh,
that's
cool.
awesome.
It's super deep and I've lost so much detail, but it's just a test. So
Looks good.
That's
Yeah,
great.
we're getting there.
And so, really quickly, Ruby, did you cut it from? Because I guess I've never rastered something that detailed at MakeHaven. Were you able to cut it from a raster image, or did you need to turn it into vectors with infills?
So I found this image on Google I put the JPEG image into Photoshop. I cleared it of all color. I turned it into a grayscale, and then I turned it into a bitmap to get it like solid, totally black and white. And then I put that bitmap into Inkscape, and then I need to look at it actually. And then I did trace bitmap, and from there I can share my screen if you want. But I from there I was able to decide how much detail I was going to able to keep, and the more detail you keep, the longer it's going to take. This took I think about 10 minutes, and it's still a pretty good amount of detail. So yes, trace bitmap, and you choose all your settings, and then after that you need to object to path, and all of that basically gets you to the point where all of these things have nodes and like the detail and everything is there. That's how I did it.
Yeah, that'd be great. That's awesome. Thank you for the recap. That's super helpful. All right, we have a couple people who've been doing things over the past little bit. And so if anybody wants to share, Ada, you're unmuted right now. Do you want
to? Yeah, I mean, I can give an update. It won't really have almost anything to do with Arduino, because although my computer is back and working now, I had been unable to work on the Arduino stuff for a while. So I was focusing on the ongoing like nightstand project that I've been working on. And what I do want to do with Arduino is there's a built-in LED lamp on the nightstand, and there's some copper inlays, and I want to use the capacitive touch library to set it up so that touching the copper inlay will turn the light on and off. But yeah, so I've been getting a lot of cutting done on that, and I was able to do like an early dry fit on some of the stuff. This is like the two of the shells from like one of the levels. Is this positioned well? I can't really.
Yeah.
And then those cutouts are all for the various inlays. And I did do a glue up of the shells, so like that's getting them ready.
And they're all like, are they still on the foundation shelf? Like, it's amazing if you walk back and see sort of what you can get off of a CNC.
They're on like the 48-hour table.
Gotcha.
Or actually, they're under the 48-hour table. I think the drawer front is on the foundations shelf though. But yeah, and so like here's just another angle.
Yeah.
And I only have a few different like big cuts left. I need to do like some so I've gotten half or 1 second. So these I actually do have here. These are like pieces of the legs that will go like between the two levels. And only about half of this is the actual piece. There's I think there's like a ridge there, which indicates where it needs to be separated. And then there's like a mating piece that has the same curve. And so this is like the outside of one leg, and this is the inside of another leg. Not the matching ones, the opposite ones. That's just like how it fit better for CNCing. So I need to do the other two of those, and I need to do a cut with copper. And I've been thinking about like how to do the actual drawer that'll go in and out, and I might do a similar CNC cut with that to get like so that the drawer could actually be curved and take advantage of the full volume.
It could
So
that could be another good candidate for flexures that you
that-
laser cut, so that you go
yeah, I was also thinking about like getting like 1/4-inch plywood, and then doing like a bunch of curve cuts in it, and
yeah, because when
yeah,
you do that, and then you can so you cut 90 degrees to how you want to curve. So if you want to bend it this way, you'd be cutting across like that, so that you
yeah,
can get the bend that you want to have. And so you'd have cuts that go sort of along the length of the drawer, so it can curve up and fit in that curved space, which would be really interesting. And then you can fill in on the bottom with like wood filler or Bondo or whatever, because it's on the bottom too. It doesn't super matter. But you'd be able to fill those spaces in, so you have all the structure back, but it
Well,
gives you the chance to bend it.
I think that it would make more sense to do it on the top, because then as you bend them, the curves will get smaller. They'll be pushed in towards each other.
Yeah, different materials roll in kind of different ways. That's totally right for like the plywood kerf cuts. The outside is usually maintained. When you do kerf cuts on the laser, you usually cut all the way through. So your kerf cuts bend slightly differently. But yeah, like it'd be a good thing to play around with and see what works best.
Okay, that's good to know.
Let's see. Kate or Anna, anything you want to share? And if you want to pass, you totally can.
I will just say quickly that I don't have very much to share. I did do a blog post about my many failures, and I've learned quite a bit through them. I definitely will be talking with Ruby more about how one goes from like completely new to this and a good approach there, because I could definitely use that. And I do have ideas for what I'm going to do. My biggest success was learning a little more Morse code and getting a light to blink different messages that I've always wanted to do more with Morse code. So that was the one thing that actually worked, both not just on the Arduino, but like an actual LED was the one thing that actually ended up being successful. There was some other chip stuff and things like that that just never really went through. I think it was Lila that was talking about sort of having a harder time sort of with the nature of this project. And so I think that I like, in the same way, I feel like I finally now have a project that fits with this, that's pulling me, so I can use some of that energy and a lot of that learning. And I've also really learned that even though this seems like a really good remote fit, that when I have no idea what I'm doing, I'm definitely more of an in-person learner. So I'm going to utilize that more as well.
Me too.
And absolutely, I'm game to be in person. And actually, I have a day and a half left of school, and then I'm on winter break until the 4th. And so if anybody wants, I know it's exciting. I still get a winter break like the kiddos. And so if anybody wants to chat about Arduino, to like get caught up, if anybody wants to do project stuff, if you want extra help with the laser, whatever, like once we get through Wednesday, I'm very available. And it's not like I'm going anywhere for the holidays. So I'm going to be around and happy to chat or work on projects or whatever. So definitely, if you want to sit down and work through some things, I'm totally in. If you want to brainstorm for the cloud, or you want to get more to happen, or you want to just sort of brainstorm what's a good project, we can totally do that. So I'm in. Yeah. And let's see. Yeah, Anna.
So, so I've been really, really struggling with Arduino, like a lot. Like I'm starting to realize that there are just certain ways my brain doesn't think, and the logic that goes behind Arduino. I mean, I've talked with Corey about this, so he's well aware. But I've just been like, it's like trying to stuff rocks into my brain, and they won't go in. So I've kind of just like really like finding out about the Linda videos. I'm going to watch some of those and just like really think about it. But I also have a sister who's an engineer who might be able to help me because she, I just realized she did this. She's been trying to do she wears hearing aids. So she's been trying to make a thing that she can carry around that lights up when somebody's talking to her, but she can't see them. So that she can turn around and face them. Because a lot of people don't realize that even though she's wearing hearing aids, she can't always detect that you are speaking to her, and she can't always understand you unless she sees you. So I was thinking of maybe like trying to pick her brain about that and seeing if that'll work. But also like most of this month I have been, I started a small business. So I built a website, and I feel like that's a better marker of the first unit than the website I did build, because it actually works. I'm gonna put it in the chat. And I had to build that with a lot of obstacles because I registered my domain with GoDaddy, not realizing that you cannot transfer the GoDaddy domain to another place until like 2 months from now, which is not, it's a gift wrapping business. So this is kind of the season for it. Cannot wait. So I had to use the GoDaddy. Oh, I just realized that is not a good way to do that link. So hold on. There we go. Let me try that again. That's a real link.
Yay.
But so I had to use the GoDaddy website builder, which is very different from like WordPress or Wix or Squarespace. It was like a completely different system. So I had to like put that all together, and I designed the logo, and I actually set up a booking system for people to drop off and pick up their gifts, which was an interesting process in figuring out how to make a widget work for you. And then I also connected it to a Facebook page so that if people find me on Facebook and they message me, it also is the same messaging system on the website. So if somebody's on the website and messages me, it also feeds into Facebook Messenger. So I get it on my phone. So yes.
That's
so
incredible.
that's kind of what I've been up to. I'm in the middle of a 28 gift order right now.
Yeah.
Yeah, so that's kind of what I've been doing all month, is like just trying to make money and do this. But I have exciting plans for the vector design. I have a couple things I want to try. I've want to try a project that will follow through to CNCing possibly, which is, I was asking questions about this in the Slack for MakeHaven about laser cutting chipboard into these very simple shapes for earrings so that they're very, very light. But then also using the vinyl cutter to actually add the color and detail on top of the laser cut shapes so that you're making super light, super colorful earrings that are, for the most part, like not very difficult to produce, but also like not plastic. I know the vinyl is plastic. I'm looking for an alternative to the vinyl right now. See if there's like someone's created an eco-friendly vinyl, but I haven't found anything. But the plan is to create earrings with the laser cutter and then try making it with the vinyl cutter, and then also trying the same project with CNCing and seeing what the different results are and comparing. But I don't think you can CNC chipboards. I have to think of some other material.
You can CNC lots of things. One thing that would be really cool, and now that you describe that part of the process, I'm wondering, we should get you in contact with the molding and casting facilitator, because you could laser cut and then like finally detail out your design, and then you can use like an eco-friendly resin to pour in, and you can color those in advance so you can get the exact shape that you want and then pour them out of resin so that they are plasticky, but if you get the right material, it can almost feel like glass, but you can color and shape it however you want.
Yeah, I was also thinking of potentially screen printing I have to see if this is possible because I don't even know, but I've screen printing the design onto the chipboard first and then laser cutting it. Like the detail of the design. For example, if it's like I'm going to go with the pineapple. If it's a pineapple shape, I'm going to screen print the colors of the pineapple onto my sheet of chipboard, and like a couple of, like, it's going to be more than one pineapple on that sheet, and then go into the laser cutter and cut around it so that I then end up with a full color laser cut thing.
I don't know if this is of interest to you, but just FYI, the last thing I did before the pandemic was I took a laser cutting class at the library where it was laser cutting earrings, and we were using leather, like very thin craft leather, but they had some really cool effects. And what we would do was layer it, so we'd have like different shapes, but it's very light, and it was an interesting material. So there's definitely other materials. Obviously that's not going to stick well with the vinyl, but I can show you or send you what I did in that, but I definitely think
try acrylic too.
Yeah, that's the only thing. The only thing about acrylic is I have acrylic earrings, and my one thing about them that I don't like is that if you drop them in exactly the right way, they just snap.
Yeah, acrylic cracks really well. Resin would definitely be stronger for that, especially if you laid in. One of the things that's really cool about epoxies and resins is that you can lay stuff in them. And so I'm imagining like little golden fibers laid through them, which would be decorative, but it would also add some tensile strength to the compression strength that the resin has. So there's like some interesting dynamics that you can do to get sort of a small effect. You could, but the printed and then lasered is really cool. I'm imagining like a single texture just laid out, and then you pack in the like sort of a green and yellow hash across the whole thing, and then you just laser cut out a whole bunch of pineapples all in one shot.
Yeah, that's kind of what I was thinking. I just wanted to see if it was possible to just like, because I like the burning and the etching effect, but like for this, I'm looking for something that's more like, I want to see how many I can make and the quality of how many I can make. I'm not looking for like super detailed, but I'm also not looking for like, I mean, if I really wanted a pair of earrings, I could just make them myself. But this is more like, can I make 20 of them? And then maybe like, instead of earrings, I make keychains or something. I don't know. I just like the idea of combining mediums, like screen printing and chipboard, laser cut chipboard, and then combining vinyl cutting with that as well. I just want to see like the layering of different processes and how that comes out. That's really where my interest lies.
Yeah, that's really cool. I feel like there's tons of opportunity, and like Ada has some experience making jewelry. I bet you guys could have some good conversations about what are good strategies, what are bad, what are like things that definitely work, things that definitely don't work. How do you cross the streams and blend strategies so that you get new things that might be better to batch out, right? So that you can sell them on Etsy or whatever it is you want to do.
Yeah, and then one really quickly.
Yeah, I mean, I'm happy to talk. Oh,
go ahead. No, I was gonna grab the earring that I'm trying to.
Oh yeah. I mean, I'm happy
listening,
to
though.
talk about that, but just in terms of like, I'm not sure that like, and maybe in terms of jewelry design, I would have some sort of additional expertise, but like all of my stuff is metal. So like I'm not sure that in terms of material recommendations or things that I would have that much to offer.
I mean, I will definitely like probably need some like design, a little bit of design help for like.
Yeah, I'm happy to talk about that though. Yeah.
But this is a laser cut wood earring that's
cool.
been then painted.
Oh, it's Navi. Yep.
Nice.
And then,
yeah, that's really cool.
So that's where I got the idea from.
Yeah, that's really neat. I feel like the amount of things that in Cleveland, there was a thing called the Cleveland Flea, which is a flea market of people making and selling stuff. I'm sure there's something analogous when New Haven isn't in lockdown. But the amount of things that I'm like, oh, that just rolled straight off of a laser, or that was CNC'd, like those things you'll totally be able to do as we develop. And especially like this week, this is the week where we're going to start and hammer out those skills where you can be like, how do I make 1,000 of this thing? And maybe not 1,000, but like you could make 25 of something just as easily as you can make one of them. So there's some really neat opportunity. And then if you're thinking about it that way, as you imagine your designs, you'll make different choices about rastering versus vectoring, and like how you choose to add in depth or color or texture or those things, which is really cool. It sounds like people have been doing lots of fun things, and we're at 9 o'clock. We should probably wrap this all up for our recording officially. But it's really cool to see what everybody's been up to. There's tons of cool opportunities. If you want any help going over anything, I'll totally be around and available. And if you want to, you just send me a message so that I know to be there at the right place and time. Or if you want to schedule a call, we can totally do that also. And if you feel like you're behind on anything, doubly so. Like that's totally true. And if you want to talk about things where we're going, and if you want to talk about laser stuff, I'm all in. I'm just here for support. Is mainly what I'm trying to say. I'm here to back you up. So if you need anything, please let me know.